All right, so now that we know what a function is, each x maps to only one y value, and then to have an inverse, we should know that each x maps to a unique y value. Let's talk about the function y equals 7x. We want to know how to find an inverse. You had a problem in the book that gave you some examples, some methods, I think it was number 7, of how to find inverses. So f of x equals 7x. You could rewrite that as y equals 7x. My method of choice, I usually switch my y's and my x's. So I'd have x equals 7y. And then y alone. So I'm going to divide by 7 on both sides. And my final answer will be x over 7 equals y. So we would note that our inverse function equals x over 7. Let's try another one. If I have x plus 2, remember we can write that as y equals x plus 2. That's just a line. Definitely one does have an inverse. We switch our x's and y's. X equals y plus 2. And to get y alone, I'm going to subtract 2 from both sides. So I have x minus 2 equals y. Therefore, we say our inverse of x plus 2 is x minus 2. Inverses could also be thought of how to reverse the operation. If someone tells you multiply by 7 to go forward in a process, you're going to take your answer and divide by 7 to reverse it or find the inverse. Now, for this last one here, we could rewrite this as y equals 2 over x minus 3. This one's a little trickier. Let's switch our x's and y's. So I have x equals 2 over y minus 3. This is a unit. You can't just rip things out of the denominator, so we're going to multiply by y minus 3 on both sides. And we'll have x times y minus 3 equals 2. To get y alone, remember that's our goal, to get y alone, let's divide by x on both sides. So I got y minus 3 equals 2 over x. Now to get y alone, I'm going to go ahead and add 3 to both sides. So I'd have y equals 2 over x plus 3. Our inverse function then would be noted as 2 over x plus 3.